My name is Pilcifer Kookie Beans, and I stole this mediocre YouTube channel. Computerized photo typesetting, front end systems. With the greater versatility of photo typesetters came the need for more command codes to be included in the text tape. The keyboard operators no longer had to make line ending decisions, but much of the time they were working blind when putting the codes in the text. They could not see the effect of the codes or know where a line was going to break until the type was run out on the photo setter. And corrections had to be set separately and cut into the original repro or merged into a new pinched paper type, which was used to rerun the entire output. Thus was born the front end system. In its simplest form, it was a computer which processed a keyboard input to determine line endings, identified many coding errors, and sent the resulting text and codes to the photo typesetter. The transfer to the typesetting machine was something by paper type, but often took place over a cable connecting the computer and typesetter, directly referred to as being online with the typesetter. More importantly than the line ending decisions, which many photo typesetter machines were capable of making themselves, was the storage of the keyboard text on a computer disk. This meant that the file is accessible for correction and updating at a video display terminal and could then be reprocessed to produce correct output. It also became possible to call the file up on the terminal after the line endings had been determined to check the results and make changes if needed before sending the file to the typesetter. If something did not fit the way the operator expected, it was a simple matter to change the command for the type size, line length, or leading and process the file again. Another very useful feature of front-end systems, which had been present earlier in some photo typesetting machines, was the use of stored formats. This allowed the typesetter to store a a series of codes and texts if appropriate, which might be needed repeatedly. For instance, to set a subhead in the book, the codes to establish typeface size and position could be stored once and then recalled with a single command each time they were needed. Even more important was the ease of making changes. If individual codes were used in the file, then changing the point size or the other parameter will require finding and changing each occurrence of the codes. With stored formats, only the format definition is needed to be changed. The new codes would then be used by the computer each time the format call was encountered in the file. Most front-end systems store kerning tablets for each font, which define minute spacing adjustments to be made between certain pairs of characters such as T, R, and A. These adjustments can also be stored in the typesetter. CompuGraphic offers a sector kerning in which the lines of each character is divided into several horizontal bands. A minimum distance to adjacent letter for each of these bands is stored with the character information and font. The machine and then evaluates these minimums for each character combination. The typesetting uses the smallest available allow for the combination. The early front-end systems did not show different typefaces on the screen on the position with X. The screen showed the text with the codes in the place or the brightness or the reverse video to indicate italic boldface coding, but the codes used by many front-end mnemonic made them easier to remember and use the actual typesetter for codes from many machines. The computer then translated these to typesetting commands, then it processed the file. Digital typesetters. The next major step in photo typesetting took place with the introduction of the second generation machines which produce their image from digital information rather than from an actual image. Digital description of the character stored on a computer disk uses display the letters of the face cathode or A tube CRT. The character is not exposed on the photographic paper and on the film by direct contact or the face of the CRT by the projection of the tube on the photographic surface. The Hale Digest was the first typesetter to utilize fonts stored in a digital form. It was utilized in 1967, and the RCA offered an adaptation in the United States as the video comp. Other CRT typesetters introduced about the same time were the Mergler Lunatron 1010 for the U.S. government printing office, the Lunatron 505, and the Harris Type Phototronic CRT. The Mergenthaler machines produced by the CRT image by scanning characters physically sorting the typesetter. All of these early CRT typesetters were expensive high-speed units designed for the large volume output for the such as directories, database publishing, and newspapers. Lower priced digital typesetters between 1975 and 1980 included the Harris Intertype 7400, Mergenthaler, Thinglotron 202, Alpha Type CRS, and Graphic 8600. These typically offered size ranges from 4 point to 48 or to 72 point, and line lengths from 45 to 108 picas. Output speed ratings were also as high as 1,000 newspaper lines per minute, although they varied substantially depending on the type size, and the number of font changes required. The Alpha Type CRS achieved the resolution of 5,300 lines per inch by using a double sweep of CRT screen, resulting in somewhat slower output. Fonts were usually stored on floppy disk or hard disk in the typesetters and usually called into memory as required. While the disk could hold many fonts, not more than two or three could generally be in memory at one time. Therefore, frequent font changes required loading and reloading from the fonts from the disk, which slowed down the output. It is worth noting that the Alpha type and Harris Center type machines used up to 5 different font masters to produce their type size, while CompuGraphic could produce all sizes from one master. Mergenthaler took the middle road, offering many of their devices in 2 or 3 different master sizes. The different sizes would be sold separately, however, and in practice, few typographers brought more than one type size to a font. The Linotype raster image typesetters use a single master font for all sizes. They use CRT typesetters and digital fonts to produce a generation of faster, more reliable typesetters. Most of the new machines required little, if any, movement of lenses, font masters. Such mechanics, function, and optical prototype sorters had been a source of reliability problems, both in breakdowns and in maintaining the necessary precision of movement. Digital typesetters also usually offered a great range of typefaces and the ability to have more fonts on the line at one time. There was some loss of character sharpness through the use of CRT images as compared to those projected from a film master. However, the resolution of the typesetters was typically 1,000 lines per inch, and there was a visible deterioration in quality on usually the size larger, depending on this set of the curves. The laser age. The big news of the 1980s have been the incorporation of graphics capabilities into video display terminals and prototypes. So the use of terminals which could display text and graphics in their proper position have been made typesetting systems easier to use by eliminating much of the memorization code, placement of an illustrator and block or type. Capable by moving the element to the desired position on screen and allowing the computer to give the necessary instructions to typesetters. In fact, such terminals and microcomputers have become known as WYSI WYG. What you see is what you get systems. On the opposite side, laser typesetters have become the primary means of transferring the phototypes and graphics image to the film and paper. In many ways, laser typesetters are similar to the CRT machines. They use digitally stored fonts to create an image by turning a beam on and off at the proper moment as it moves across the surface of the paper. The most common CRT units build the characters with the short vertical strokes and the length of the type size, placing them one after the other as it moves across the paper, while laser units usually scan beams down across the paper, slightly downside with a successive stroke. See figure 16, period. Close parentheses. Laser typesetters rely on a raster image processor to assemble the text and illustrations on the page for the actual image transfer. The raster image saves the picture of an entire page. This picture is broken down into millions of tiny dots of pixels, which are either important or the laser beam then moves across the page many times to cover the entire range and turning off and on according to the raster page image. Since the beam is painting the whole area, it is immaterial with only the typesetters in this category, often denoted as a fourth generation machines. Not all raster image typesetters lasers, however, others such as the ITEC IGX 7000 used a bank of LEDs, light emitting bars from the form the image of the CRT. The unifying factor is the preparation of a page with type photographic medium. Primary disadvantage of rasterism at present is their low rate of speed compared to the character-based CRT typesetter. Direct comparison to about a page of type, which might be take 30 seconds on the typesetter, may take several minutes on a raster typesetter.